Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter. T minus 7 seconds.
Bill Nye the Science Guy.
Waves. What are they? Where did they come from? Why do waves look the way they do? Why do I care?
Waves are a wiggle in space and time. They don't exist in one place, but rather extend from one place to another. Waves are all around us in the form of sound and light. Light is a form of transverse wave, like this laser, and sound is a form of longitudinal wave, like this music box.
Transverse waves look like up and down movement. The motion of transverse waves is at right angles to the wave itself and the direction that it travels. Longitudinal waves look like back and forth movement. The particles of longitudinal waves move along the direction that the wave is traveling.
There are several properties of waves. There are crests, which are the high point on the sine curve, or there are troughs, which are the low points on the sine curve. The distance between the top of a crest or the bottom of a trough and the midpoint is called the amplitude. And the distance from crest to crest or trough to trough is the wavelength. Waves also have speed. Wave speed is measured by multiplying wavelength and frequency. But what's frequency, you ask? Our buddy Sal Khan has the answer.
So how many cycles per second? That's the inverse of period. So period, the notation is normally a big capital T for period. This is frequency. This is frequency. Frequency. Frequency, it's normally denoted by an F. And this you're going to say cycles per second. So if you're going 5 seconds per cycle, that means you're doing 1/5 of a cycle per, or 1/5 of a cycle per second. All I did is invert that right there, and that makes sense because the period and the frequency are inversions of each other. This is how many seconds per cycle. How long does one up, down, back again take? And this is how many up, down, back agains are there in a second. So they're inverses of each other. So we could say that frequency is equal to 1 over the period, or you could say that period is equal to 1 over the frequency.
Thanks, Sal. To summarize, frequency is how often a vibration occurs. For example, look at this clock. The second hand on the clock goes around once every 60 seconds, making its frequency 0.016 hertz. Objects can have high frequencies or low frequencies. An increase in frequency is known as a blue shift, but a decrease in frequency is known as red shift. The apparent change in frequency due to the motion of a source is known as the Doppler effect. Here we have the Doppler ball signs to demonstrate the Doppler effect. Another good example of the Doppler effect is when a car drives by while it's honking its horn. As it drives towards you, the sound waves compress together and make the pitch sound higher. And as it drives away, the sound waves spread out and make the pitch sound lower. Waves spread out in all directions. Sometimes they overlap, and that's called interference. Constructive interferences occur when the crest of one wave overlaps with the crest of another, causing the waves to add together. But destructive interferences occur when the crest overlaps with the trough, resulting in a smaller wave.
Waves are all around us. Their properties impact what we see and what we perceive. They transfer energy and information, allowing us to understand the world around us.